All right, this is our last topic of the summer prep, so hopefully you guys have found these at least educational, and hopefully this will help you come the upcoming year here in calculus. This particular topic is called decomposing into partial fractions. This is definitely something, if you are in BC calculus, this will be important. This is one of the more advanced techniques that you get, and you'll get to that later on in the year. But this is an important topic. So what does it mean to decompose into partial fractions? Well, as you can see here, what I have is I have two rational functions. Okay, they are each individual, just one fraction. But I can break each one of these things down into partial fractions. Well, let me show you what I mean by that. Let's take it the other way. Okay, we're going to do something that we've already seen before. Let's say we start off with something very much like 1 over, let me move this. I'm going to put this underneath of number 2, even though this has nothing to do with number 2. So let's just kind of wall this off here. So this is just an example. So we have 1 over x plus 1, and we want to add that to, let's say, I don't know, let's just call it 1 over x minus 2. Okay, if we want to add those two things, we know from previous work that we have to have a common denominator. And the common denominator here is going to be x plus 1 times x minus 2. So in order to get that common denominator, I'm going to have to multiply this first one here by x minus 2 over x minus 2. And I'm going to have to multiply the second one here by x plus 1 over x plus 1. And that will get me my common denominator. So the common denominator here is going to be x plus 1, x minus 2. X plus 1, x minus 2. But my numerator here, the first one's going to be x minus 2 when I multiply that times the 1. The second one's going to be x plus 1 when I multiply it by its 1. And then when I go ahead and combine these two things, what we're going to get out of that is we're going to get 2x on top, and then the negative 2 and the 1 is going to give me minus 1. So what you can see is, obviously, I don't end up with just 1 plus 1 on top. I can't do that. And then I'm actually going to erase the denominator here because we're going to multiply that out. So x plus 1 times x minus 2, if we just use our FOIL method there, is going to be x squared minus x minus 2. So what you can see is I definitely have a rational function, very much like you see in number 1 and number 2. Number 2 looks a little bit more challenging, and it is. It's going to take some more time. But number 1 isn't going to be that bad. But what you can definitely see is I can't just take the 4x and the 34 and split those on top of the denominator. So the first thing that we're going to have to do is we're going to have to figure out what does my numerator have to be in order for me to add those things up and get the 4x plus 34. Well, as you can see here, my original numerators on the ones that we did over here were 1 and 1. Okay, that doesn't look like the 2x minus 1 right here at all. They don't look the same at all, and that's because of the way we have to do it. So here's what we have to do. And it's a bit of a process, but it's not horrible. It just takes being careful. Very first thing you have to do, and I'm going to go ahead and erase all this stuff on the right if I need room, but we'll see if I can leave it up there. First thing you need to do is you need to factor the denominator. And the ones that we're given here are presented in a way that this is going to be possible to do. There are some of these, and there are other forms of this which you will learn more advanced of later on. But these are all possible at this point. So let's factor the denominator. So that's going to have to be x and x. Let's see, the factors of negative 24 that add up to negative 5 are going to be, what is that going to be? It's not 12 and 2. It's going to have to be 8 and 3, right? So negative 8 and positive 3. Yeah, that looks right. So the question is, when I split this up, I'm going to split it up into something that's got x minus 8 as a denominator and x plus 3 as a denominator. Again, I can't just put a 4x on top of one of them and 34 on top of the other one. It would be really nice if that worked, but as you can see from the example on the right, the original numerators do not become just adding those two things up and become the new numerator. So that's not going to work. So what we need to do is we just need to put some variables up there because we don't know what they are right now. So for right now, I'm just going to call this A. I'm going to call that B since we don't know what it is. In order for us to solve for A and B now, to figure out what these values are so that we can split this thing up, what we need to do is we need to realize that if these two fractions on both sides here are exactly the same, in order for me to get the fraction on the two fractions on the right to add up, I have to use a similar method. I have to multiply the numerator and the denominator of the first fraction by what it's missing. Well, it's missing the x plus 3. So really what I need to do is I need to multiply x plus 3 here and x plus 3 here. But that means with the b part, I need to multiply it by the part that it's missing, and that's the x minus 8. So I need to multiply it by the x minus 8 here and the x minus 8 down here. I'm really trying not to erase that stuff on the right-hand side if I can. So what I'm going to get now is I'm going to get the entire fraction on the left, which I'm going to, I'll go ahead and rewrite it. 4x plus 34 over x minus 8 x plus 3 is going to equal a times x plus 3 over the common denominator, and then b times x minus 8 over the common denominator. Oops, make that a minus 8. There we go. Now, what you could see is everything now has the common denominator. If I multiply every single piece by the common denominator, they're all going to go away. They're all going to divide out. So I don't need to worry about that. I can multiply every piece by the common denominator. Most people just start to cross them out. That's not really what they're doing, but they are going to basically go away. So what that really leaves us with is just the numerators that are equal to each other. So I get 4x plus 34 equals a times x plus 3 plus b times x minus 8. Now there are multiple ways to do this. I'm going to show you the easier way in this case. With the second problem, we're going to use a different method of this, so you'll get both methods out of this. In the first one, the idea behind this is I can take any x value that I want because this is supposed to be a true statement. Okay, this is what we're gearing towards. It is a true statement. So I can take any x value, and as long as I plug it into both sides, it should work. So let's pick x values that are going to conveniently get rid of one of my variables. For example, if I were to pick x equals 8, well, if x equals 8 and I plug that into this one right here, 8 minus 8 is 0, so 0 times b is gone. It's out of there. It's history. But I do have to plug in the x equals 8 into the other x's to be able to figure out what the a value is. So if I plug 8 into the left-hand side here, we get 4 times 8, which is 32, plus the 34, so that's going to be 32 and 34 is 66, right? Hope I did that right. And then here we get a times, if I plug the 8 in here, we get 8 plus 3, which is 11. This is really nice because now if I solve for a, I get that a equals 6 by dividing both sides by 11. Okay, we can do exactly the same idea by choosing x to be, let's see, what would make the a go away? Well, if I plug negative 3 in for x, the negative 3 plus 3 times a is going to be gone. So let's take x to be negative 3. So again, we have to plug negative 3 into all the x's. So if I plug it into the left-hand side, 4 times negative 3 is negative 12, plus 34 is 22. And then if I plug it into the one with the b part, negative 3 minus 8 is negative 11. So we get b times negative 11. Dividing both sides by negative 11, we get b is negative 2. So what that has done now is it has given us the method, or excuse me, given us the values that we can plug on top of our decomposed fractions. And we will see that our final answer to this for decomposing the first fraction is a, which is 6, on top of x minus 8, plus negative 2, which is b, over x plus 3. And this is the decomposed form of that. If you were to take the fraction that we just found, add them up, and then combine like fractions, combine like denominators and stuff like that, you would get back to the original thing that we just started with. All right, the second one is going to take a considerable amount more space, so I'm actually going to transfer this to a different page, and we're going to do it there. Okay, problem number 2. Like I said, this one's going to take a considerable amount more space. It will take more time, and it's definitely going to take more algebra. So let's go ahead and get started. The very first thing you need to do is you need to factor the denominator. We don't have to worry about factoring the numerator. We never have to worry about doing that in decomposing a fraction. So let's go ahead and factor the denominator. So if we look at this thing, again, we'll leave the numerator as it is. The first thing I see in the denominator is I have a common factor of x squared, which can be factored out. So let's factor out the x squared, which will leave us with x squared plus 5x plus 11. And if I look at that, I don't believe that we can factor the x squared plus 5x plus 11. The reason I know that is because 11 itself on the end there in the last space is a prime number, so it's only factors are 1 and 11. There's no way I can take 1 and 11 and break those up in a way such that they're going to add up to 5. So that is factored as far as we're going to get it. So from here, those are our two denominators. So let's go ahead and split this thing up. I know that I'm going to have something over x squared, and I know I'm going to have something over x squared plus 5x plus 11. Just to let you know, this one is very advanced, by the way. This is a very high level decomposition. So what you can see is normally what we would have just put on top of this, like we did in the last one, is just like an a and a b. The problem is our denominators here are both quadratic. And what you put on top is always 1 power less than what you had on the denominator. So we had a quadratic on top. What's 1 power less than a quadratic is a linear. So it's just going to be something with x. But I can't just put x on top because that's another variable. What I have to put is basically mx plus b, but we're not going to use mx plus b. We're just going to use ax plus b. Doesn't really matter. But the only thing is you're going to have to use different letters for everything. So on top of the first one, I'm going to put ax plus b. And I can't reuse the same letters for the second one, which is also quadratic. So I'm just going to start with the next letter, which is c. So it's cx plus d. If we had another quadratic, which, man, would that get real messy, we would go ex plus f, and so on. So the general idea there is whatever the denominator is, you're going to go 1 less on top. So if we had a cubic on the bottom, you would have to do some form of ax squared plus bx plus c on the top. Don't worry, we'll never do one like that in this class, but that's the general concept. Okay, so now what we have is we have the fraction on the left is equal to these two split up fractions on the right. Once again, the general idea is I've got to add what's missing, or excuse me, not add, I've got to multiply what's missing on the top and the bottom. Well, we do know that the denominators are going to go away, so we're going to kind of skip that step in this case. So we're going to go straight from the fact that the numerator, 5x cubed minus x squared plus 8x minus 55 is going to equal, let's see, the numerator over here, this one, this ax plus b, it's missing that denominator. So I'm going to have to multiply ax plus b times x squared plus 5x plus 11. And then the cx plus d part, this one, is missing the x squared. So I've got to multiply cx plus d times x squared. And this is where it starts to get a little bit lengthy, a little bit messy. We're going to have to distribute or FOIL or whatever you want to call it. We're going to have to make the distributions over here on the right-hand side. We have to get all these things separated out of the parentheses. So let's go ahead and do that. So if it helps you, write your little arrows. Just make sure you keep everything straight. I'm going to multiply the AX times this AX right here times every piece in that second parenthesis. So I'm going to get AX cubed. 5AX squared, and then 11AX. That's just from the A part. Now I've got to multiply the B into every piece over here on this in this parentheses. Whoops. Thought I clicked green. There we go. There we go. So now I'm going to multiply that out. So I'm going to get a BX squared, a 5BX, and an 11B. Okay, and that's just the first one. So now I got to come over here to this one. This one won't be as hard because I'm just distributing that x squared into here. So I'm going to have, let's see, plus CX cubed plus DX squared. All right, so here's the important thing. All of that equals what's on the left. So I do have to recopy the left. 5x cubed minus x squared plus 8x minus 55. This one is not going to be as simple as just picking a nice convenient value for x that's going to make things go away. It isn't going to work like that. So what we have to do is we have to regroup common terms. What do I mean by that? Okay, so I've got an x cubed here, and I've got an x cubed here. I have to regroup those two things together. So I'm going to rewrite this as ax cubed plus cx cubed. Okay, I'm going to group those together. I'm going to what's called reassociate them. All right, now I'm going to do the same thing with the x squared. So let's go ahead and do that with the x squared. I've got a 5ax squared, a bx squared, and a dx squared. So I'm going to reassociate all those together. So plus 5ax squared plus bx squared plus dx squared. Okay, then I have to reassociate all of my x terms, which is going to be 11ax, 5bx, and that looks like that's it. So we're going to have plus 11ax plus 5bx. Man, my 5s look absolutely horrible. 5bx. And then I'm going to associate anything that's left over because those are just constants. And it looks like all I have left over here is an 11b right there. So we're just going to put plus 11b. All right, so now what we're going to do is we're going to basically factor out the common factor from each one of those parentheses. So in the first one, the common factor is x cubed. So it's going to leave me with an a plus c in parentheses, x cubed. In the second one, I'm going to factor out the x squared. So we're going to have plus 5a plus b plus d, and then the x squared is factored out. It doesn't matter if you factor it out to the left or the right, but you'll see why I'm putting it on the right in a second here. Hopefully it'll just make it make more sense. In the last one here, we're going to have an 11a plus 5b because the common factor is x, so we'll factor that out. And then at the very end, we still have our 11b left over. All right, so why did I do it that way? Why did I write it in the specific manner that I did? I'm not going to rewrite the entire left-hand side on every step, but I am going to write it down here on the one that we're at because believe it or not, we're almost done. Doesn't look like it, but we are. What you should see is if the equation that I have on the left equals the equation that I have on the right, what I have on the left-hand side here is a 5x cubed. What I have on the right-hand side here is an a plus c x cubed. If these two things are to be equal, then the coefficient a plus c must equal the coefficient 5, because they have to be the coefficients of the x cubed. So what I know is that a plus c must equal 5. Okay, very similar on the right-hand side here. This 5a plus b plus d must equal the coefficient of the x squared on the left. Well, the coefficient of the x squared on the left here is really just -1. So I know that -1 must equal 5a plus b plus d. Okay, we're going to keep going. The coefficient, hopefully you're getting the idea here, the coefficient of the x, which is this 11a plus 5b, must equal the coefficient of the x here, which is 8. So 11a plus 5b equals 8. And then fortunately, the last one is the kind of the key. It's the primer here. It's going to tell us pretty much how to solve the rest of these, because I do know that on the last one, this 11b must be the constant. Well, the constant here is -55. So 11b equals -55. Well, that gives me a way to solve for b. And then once I find b, I can start back solving all the rest of these. So it looks like here b, dividing both sides by 11, is going to be -5. Wonderful. There's the b part. That means I can back solve the one that's right before this. So I know that I've got 11a plus, if I plug the -5 in for b, that's going to give me 5 times -5, so that's -25 equals 8. Which means that if I add 25 to both sides, I'm going to get 11a equals 33. So I now know that a, oops, doesn't equal 11. It equals 3 because I have to divide by 11. Let me erase that real quick. So a equals 3. Now that I know a and b, I can solve the previous one for d. So I've got -1 equals 5 times a is 3, so that's going to be 15. Plus my b, which is -5, plus d. So let's see, that's going to be -1 equals 10 plus d, subtracting 10 on both sides. D is going to equal -11. One more step to go. So we need a and, we need to find c, but I already have a. So I know that a is 3 plus c equals 5. So c, subtracting 3 on both sides, equals 2. That's what I needed to split this thing up. So now I can rewrite in our final form here, ax plus b. So a is going to be 3, so that's 3x plus b. B is -5, so -5 over x squared. And then from the top there, plus cx plus d. C is 2, so 2x. D is -11, so -11 over x squared plus 5x plus 11. All right, there you go. That is the partial fraction decomposition of number 2. If you followed that, that's some very advanced stuff. You're doing fantastic. If you didn't follow that, don't worry. We will go over stuff like this in much greater detail. Actually, the things that we go over won't even be this complicated. So if you followed that one, you're doing outstanding. Hopefully that wasn't too bad for you guys. I apologize for the length of the video. Tried to keep it under 20 minutes. Didn't quite make it. But if you kept up with all these videos throughout the summer, congratulations. And I really hope to see you guys again very, very shortly.